As a researcher, a lot of your time is spent trying to communicate your ideas and discoveries to your fellow scientists. And the standard way in which this is done is by writing a scientific paper. Communicating your ideas is awesome, but writing the paper is shit.
Communication is part of the process of doing science. It's not a kind of thing you do at the end. It's part of the very fabric of...
If you think like, what is education? Like, you're basically downloading data and algorithms into your brain. It's amazingly bad in conventional education, because like, it shouldn't be like this huge chore.
When you discover something new or figure out how to solve a problem, you want to tell everyone about it. So you want to tell your colleagues so that they can say, oh, that's cool, and you're showing off a little bit. But you also want them to know, because you want them to help you think, what can we build with this? Like, how can we use this to solve other problems? And this whole interaction thing is very fun. But currently, how scientific papers are written, they are a very inefficient means of accomplishing all that. Especially to new people, the papers are dry, very abstract, and don't do a very good job of communicating the author's ideas. So, for example, I was working on my master's thesis, and there was this finite state machine that did something. It was an old paper, and the figure was given, and it was described in text how the thing worked. But I really only understood how it worked when I read the paper so many times and thought about it so much that I could see the thing working in my head, like an animation. And I thought that had the author had the time or felt the obligation to provide this animation on some other platform than the journal, I wouldn't have had to spend that much time. So the sum of time that is wasted for all researchers is huge. Ridiculously huge. I'm currently a master's student at QTech, and I've taken the opportunity of having multiple published PhD students right next door to ask them how they feel about all that.
Yeah, got that.
Okay. So, would you please introduce yourself?
Sure. My name is Kenneth Goodenough. I'm a PhD student in the Vít/Stephanie's group here, officially in the Vít's group. And obviously I've been busy with my PhD for now about a bit more than 2 years. And I work on quantum communication, the theory of quantum communication, and I work mostly on distributing entanglement in quantum networks and how to do that most practically.
You've written a few papers already?
Yes.
Would you please describe your feelings at different stages of writing a paper?
It depends very strongly on what kind of project you're working on. So the first paper I worked on, this was a collaboration with some experimentalists. So there, the process was relatively simple. I mean, I just worked on the appendix, and all the difficult experimental things were actually done by the experimentalists. The project after that was even easier. I actually didn't write anything for the paper, just had to read through it, but I contributed something to the programming. So the first two papers I worked on were, from a writing perspective, quite simple. And for the third paper, which was actually my first author paper, there, I had to do almost all of the work. I came up with first drafts of what I wanted to have in there. And what became apparent to me, which is at least now very clear to me, is that you can read academic papers and think you can emulate that style, but it takes a lot of practice before you actually realize how a good paper is written. So I came up with a draft, and this was almost completely removed again. Because it wasn't written in a very clear academic way, so I had to basically rewrite everything. And this is something that has happened more often, but I've become better at this, so it involved less rewriting as I went along.
Okay, so that's the most difficult part in writing a paper, just to make the draft, just like to make the text clear enough to guide them through the thing.
Yeah. If there's no science to be done anymore, then I would say indeed that's the hardest part. And otherwise, it's trying to make it a consistent and an appealing story for people to read.
But an appealing story can be sometimes told more effectively if you can use gestures and point at the different equations and terms and show how they are related to each other by moving your hands. But this is not allowed. This is not possible when writing a paper. I mean, you're not even allowed to make like informal analogies.
Sometimes it can be hard. First of all, with writing a paper, or at least, putting down really your thoughts on what you want to say with the project, it's nice because, well, in a certain sense, it's a sort of conclusion of your project. And it's nice to put things concretely down on paper. And it also forces you to think about your project in a very different way. Like, how are you going to explain certain things that might seem super obvious to you, but to people who have never seen your project or the problem, this might not be obvious at all what you're looking at.
Yeah.
So this forces you to take, to step back and think again about your problem in a completely different fashion. And some things can be, of course, not so nice when you write something and you realize the structure of the paper is not clear at all, or some things are out of order, and then you have to rewrite a lot of stuff, and this can take a lot of time.
So I get this feeling that when you're doing some math, trying to describe it in text is a very bad approach. So you're over-engineering. So you're trying to describe something that's not meant to be described in text using text. It's like having a very large figure, and instead of showing the figure, you just describe it in 4 pages of text. So clearly, sometimes trying to explain your result in the austere bare minimum style you're restricted to when you're writing a paper can be as backwards as when Kevin was doing his small talk in the office.
Sometimes words need use, but need for talk.
But save time. More success.
Does it save time, though? Because we've been here for about an hour.
No me fault.
It's not only frustrating for the readers, it's also frustrating for the authors, because most of them can't in good conscience, or because the referees can't understand what they're saying, publish something that's obviously not clear enough. Although explaining your results in as clear a way as possible is crucial to science, it takes a lot of effort and time to make something that clearly explained. And I'm not just talking about adding figures or animations, I'm talking also about the math itself. So it very often happens that the proofs are inaccessible and can be streamlined, that a paper doesn't get noticed until that happens. And again, it takes a lot of time to do that. So we can't expect 1, 2, or 3 authors to put in the time and effort to do that while working on the main result itself. Because also everybody wants to see the result reasonably soon. So this is where what I call open source physics comes in. So Jonas and I were talking one day, and we thought that it would be very interesting to have like a GitHub for physics. So you have an idea, you put it up on this website. It's just an idea, and anyone can take a look at it and help you finish it. And anyone can contribute to it. Anyone can prove a lemma here and there, and we would finish this paper on GitHub with 50 plus authors or something. So you work in quantum information theory. Would you be interested, for example, in getting an idea one day and just putting it on GitHub and have people like Mark Wild or?
Yeah. I think this requires people to be open-minded and not be too how do you say
Protective of their.
Protective. Let's call it protective. Of the things they're interested in. And I think this would make lots of sense, because there are plenty of problems that just require maybe just a little different point of view. And that's something like this is perfect for that.
Yeah.
So I guess you might also be familiar with the, I forgot the name of it. It's a project but they're for math. And like some very, very famous people have worked together on this, like Terence Tao. And they'll have like some projects, and they work on it with like basically everyone that's interested. And then they also publish like a paper, and then there's like only a single author, which is like basically just a pseudonym for all the people who've actually worked on it. And quite interesting things happen there.
Really?
As an example, there was Yitang Zhang, I'm not sure if I'm pronouncing his name correctly, he found that there should be, there's some number, there exists some number such that there exist infinitely prime pairs that satisfy P and then P plus that number. So people are interested in like the twin prime conjecture, which is okay, are there infinitely many twin primes, which are primes that differ by 2, you know, like 11 and 13, 5 and 7. And Zhang proved that there exists some number such that there are infinite of them, and this number is finite. But this number was huge, like, I don't know, like 5 million or something. And then with this project, one of the iterations of this project, they worked on, okay, let's get this number down. And they got it to like 100 and, I think like 100 or something maybe. So yeah, like interesting projects like this, they're done at least by mathematicians. Yeah.
And anyone can contribute.
Anyone can contribute. Yeah. It's mostly just done on blogs, actually. Quantum info is not, or in general, you know, theoretical physics is not too far, you know, should also be able to work in a setting like this. Yeah. So I think it's definitely doable and it should be done.
So you'd be interested in.
Mm-hmm.
Cool. So I came up with this idea, or I was inspired to come up with this idea, or I was inspired to come up with this idea. So on this GitHub thing, everyone can just go to the repository and write down what they think, prove something, do some math, make a pull request, and the paper grows, or the idea grows. And in the end, you can publish that. And because it's so available to the public, it's available to anyone. A lot of smart people who do not have access to the traditional academic collaboration system will have access to that and will help you finish your research. And you will feel less frustrated because you don't have to do the small stuff, so you don't have to hunt for issues yourself while you don't have the mental freshness. So a lot of time is saved. It's very efficient, I think.